All right, I'm pretty sure we did this problem, but you probably lost track of your work. So this is the rod, and the basic idea of this problem is usually we did center of mass of objects, but the mass was located at a specific location, so you just would take its location times the mass, sum all those up, and then divide by the total mass. If you have mass spread out uniformly, or not uniformly as in this case, you change this to x dm over dm. The idea being that you take a little piece of it, and this represents the small piece, dm. It's like a fraction, like you could also think of it as delta m, except we're going to integrate. And you multiply that by x, and adding them all up is done through integration. This lambda is a measure of mass over length, but we can also think of it if we have a little piece of length, dl, we can say we have a little bit of mass dm. In this problem, this little piece of mass, which we might say is dl, also has the length of dx, which makes more sense because it's along the x-axis, so it's just a little sliver of the object. If we say lambda is dm over dx, and it's equal to this 50 plus 20x, the way we write dm is as 50 plus 20x times dx. So substituting it into this integral on the top, we have x times 50 plus 20x dx, and on the bottom we just have the 50 plus 20x dx, because that's just the mass. In both cases, the limits are going to go from 0 to 30, as long as I have my units right. Is this... I just want to look at your problem. It says mass per unit length. Oh, lambda is in grams per meter. That's important. This is in grams per meter. So my limits are going to change from 0 to 30, because it's 30 centimeters, it's 0.3 meters. These integrals are pretty easy because they're just polynomials. It's 50x plus 20x squared is the top integral from 0 to 0.3. The bottom one is just 50 plus 20x dx from 0 to 0.3. The top one, when we integrate, we got 50x squared over 2 plus 20x cubed over 3, and you evaluate it at its limits. And the bottom one is just 50x plus 20x squared over 2, evaluated at 0 and 0.3. So I think you can find that, do the substitution in there. And that is where your center of mass will be. That will be your answer.